So in this lesson, we are going to see how to solve probability situations or probability problems using tree diagrams. We had briefly looked at what tree diagrams are. We had done some few numbers on them, but basically today we are going to focus on probability tree diagrams. So we have our first problem. So which problem? So we are saying two balls are randomly drawn without displacement from a bag containing 10 white and 6 red balls. So we're requested to find the probability that the second ball drawn is red, given that the first one was white. And then the second one, we are requested to find the probability that the second ball drawn is white. So we are going to begin by constructing a simple box. Or we can call it a bag, something that would be just simple. And then from that bag, we have 10 white balls and 6 red. So we are told that two balls are randomly drawn without replacement. So we are going to take away two balls from the bag. So remember, since it is without replacement, the number of balls is reducing. So we need to construct some other bags here. So on the first one, assuming we picked a white, how many white balls would remain in the bag?
9.
9. So we are going to have nine white, and then the red ones are going to remain 6. Then suppose we picked red, what remains in the bag? If we picked red, what?
10 white balls and 5 red balls.
And 5 red. So that is the first picking. Then we again pick for the second time. So since we are not going to pick again there, so we now rush and look at the probability values. So what will be the probability of picking a white ball from the first bag? When we are picking the first time, what will be the probability of picking white? Remember our formula of probability of E is equal to number of E. So this we divide by number of sample space S. So the probability of picking a W is going to be 10 divided by the total, which is 16. So this is going to be 10 out of 16. Then this lower one is going to be 6 out of 16. When we got this upper bag here, where we picked a white, so this is going to be 9. out of 15, which is the total. And this is going to be 6 out of 15, which is also total. So when we move downwards here, the probability of picking a white is going to be 10 out of 15. And then the probability of picking red is going to be 5 out of 15. Then we now begin to answer our question. So the first question is that the probability that the second ball drawn is white, red ball, probability that the second ball drawn is red, given that the first ball was white. So we are going to look at a situation where we are first picking white, and then it is followed by red ball. So Roman 1, we are going to look at probability of W1 intersection red 2. So where we are first picking a white ball, and then it is followed by picking a red ball. So this is going to be 10 out of 16. We multiply it by 6 out of 15. When we do the calculations, what do we get? 10 times 6. 10 times 6, we can use still the chart, or we can do all of it at once. 10 times 6 and then 16 times 15.
Teacher, the general answer is a quarter.
Is a quarter. Okay, thank you. Are the rest getting the same answer? Okay, so we proceed to Roman 2. So Roman 2, we are requested to find the probability that the second ball is white. So that probability that the second ball is white, so we are going to pick probability W1 intersection W2 plus, so where we have the second ball being white, plus R1 intersection W2. So this is still probability. So this will give us 10 out of 16. We multiply it by 9 out of 15. Then we add 6 out of 16 multiplied by 10 out of 15. So someone can get for us the answers there. So this would be 90 out of 240. Plus 60 out of 240.
Teacher, the general answer is 5 out of 8.
5 out of
8.
8. Thank you. So then by doing this, we will now be done with question 1. Any questions before we proceed? Jacobs, Jemima, Becky, any questions? Okay, I think let's proceed to question 2. Who can read for us the second question? Anyone to read for us?
Box A contains 4 red sweets and 3 green sweets. Box contains 5 red and 6 green sweets. Box A is twice as likely to be picked as box B. If a box is selected at random and 2 sweets are removed from it, one after the other without replacement, find the probability that the 2 sweets removed are of the same color.
Okay, so some bit of correction. So the box A contains 4 red sweets and 3 green. Then box B contains 5 red and 6 green sweets. Box A is twice as likely to be picked as box B. They're saying if a box is picked at random and the 2 balls are removed from it, one after the other without replacement, we find the probability that the 2 sweets removed are of the same color. Now, we are going to still begin by drawing our, so we are going to begin by picking a box. So we are going to begin with our 2 branches. But then somewhere we had, let me think do that in this corner here. That box A is likely to be picked, is twice as likely to be picked as B. So we are likely to pick B 2 times before we are likely to pick A 2 times before we pick X. So we are going to let the probability of B to be X and that of A now becomes 2X, and the total probability gives us a 1. And so we add 2X plus X is equal to 1. So this gives us 3X equaling to 1. Then we divide it by 3 both sides, and then X becomes a third. So if X is a third, it means the probability of picking A is 2 times a third, which is 2 out of 3. And the probability of B is 1 out of 3. Then now after picking our boxes, then from each box, we now pick 2 balls. So let me draw some simple boxes here. Okay, I've done the drawing first so that I should be able to be a bit faster. So here in box A, we have 4 red and 6 green. Now, so here we are going to pick red or green, red or green, red or green. So still here we're going to pick red or green, red or green, red or green. So if we do that, so here the total in the first, if for bag A, when we are picking red, its probability is going to be, the total is 7, so probability is going to be 4 out of 7. So this is going to be 3 out of 7. Then if we pick the red board reduced to 3, this one also remains 3. So here, since there are 3, 3, it's going to be 3 out of 6. And still here, 3 out of 6. Then we move downwards. If we pick green, we are going to remain with 4 red. And then 2 green. So the probability will be 4 out of 6. And then 2 out of 6. Any questions before we proceed? I can go ahead. So we come on this lower part of box B. So this was box A. So this is box B. So the probability here is going to be 5 out of the total, which is 11. Here is going to be 6 out of the total, which is 11. So if we pick red, we are going to remain with 4 red and 6 green. Down, if we pick green, we are going to remain with 5 red. And then the green one is also reduced to 5. So the probability of picking a red here is going to be 4 out of 10. This is going to be 6 out of 10. Then down here, you're going to have 5 out of 10. And still here, 5 out of 10. Is that clear?
Yes, teacher.
Yeah. So now after drawing our tree diagram, then we go back to the question and find out what it exactly required us to do. So the question wanted us to find the probability that the 2 sweets removed are of the same color. So where do we have the same color? Where do we have the same colors? So allow me to grab off this. So the same colors, let me illustrate them. So we are going to have red and green. Are we there? Then we shall have another red and red here. Then we shall have green. That the first one we are picking bag A. On the first one, we are going to pick so this is going to be probability of A intersection R1 intersection R2. Then also have A intersection green 1 intersection green 2. So that is for A, for bag A, we are going to pick A and green. Then we add, when we are picking from bag B, probability B section R1, R2. Then we add B intersection green 1 intersection green 2. So we shall have the first one is 2 out of 3. That is for A times 4 out of 7 times 3 out of 6. Still for A, 2 out of 3 multiply it by green, the first green, and then the second green, which is 2 out of 6. Then we add, now we go for B, which is a third, times the first red, 5 out of 11. Then again times 4 out of 10. Then lastly we add, we pick green, which bag B, which is a third, times 6 out of 11. Then times 5 out of 10. Two times 4 times 3. So someone can give us an answer for the first bracket, the second bracket, the third, and lastly the fourth. So we can get our calculators busy.
Teacher, the first bracket is 24 out of 126. And then
Okay,
the second bracket is 12 out of 126. The third bracket is 20 out of 330. The fourth bracket is 30 out of 330.
It is 330?
Yes,
Okay.
teacher.
Then when we add and simplify,
Teacher, 101 out of 231. 101 out of 231.
we can guess. 101.
Out of 231.
231. Is it
Yes,
like that?
teacher. Yes, teacher.
Okay, good. Anyone with the question? Then we have our question number 3. Two boxes P and Q contain white and brown cards. P contains 6 white cards and 4 brown cards. Box Q contains 2 white cards and 3 brown cards. I think there was some repetition. So we are going to take only the first ones. Let me just edit it. So Q, I think the statement was repeated. Q contains 2 white cards and 3 brown cards. Let me just first edit it a bit before we proceed. So we said P contains 6 white cards and 4 brown cards. Box Q contains 2 white cards and 3 brown cards. A box is selected at random and a card is selected. Find the probability that the brown card is selected. Roman 2, box Q is selected given that the card is white. So we are going to still begin by drawing our 3 branches, which are 2. So here we are first picking the box, and then from the box we pick. So if this is P, if they have not given us a condition, the probability is a half. Then this would be Q, the probability is also a half. Then we kind of draw what is in P and what is in Q. So in P, we have 6 white and 4 brown. In Q, we have 2 white and 3 brown. Then they are saying from this, we pick or we select a card. So we're going to just select a card from any of the boxes. If we do that, the probability here, if we pick a white, is going to be 6 out of the total, which is 10. If we pick brown, it's going to be 4 out of the total, which is 10. Here, if we pick white, it's going to be 2 out of the total, which is 5. If we pick brown, it's going to be 3 out of the total, which is 5. Then now our tree diagram is complete, and then our duty is to find the probability that the brown card is selected. So Roman 1, probability that we are selecting a brown card. So I'm going to select it in P or in U. So it's going to be probability of P intersection B plus probability of Q intersection B. That is where we are picking a brown card. So this is going to be a half. A half, we multiply it by brown, which is 4 out of 10, the probability of picking brown from box P, and then a half for probability of picking Q, then times probability of picking a brown ball from Q, which is 3 out of 5. And then we multiply, so this is going to be 4 out of 20 plus 3 out of 10. So if we add this,
Teacher, the answer is a half.
using a calculator,
A half.
which value do we get?
A half. 1 out of 2.
What did we get when we add? Got for Roman 2. Roman 2, we have that box is white. I think that is the best way to represent our information. Box Q is selected, so probability of Q, given that the ball is white. So we say this, we define it as probability. Yes, I've seen a message in the chat. Q intersection W divided by probability of W. Okay. See, I have. So we first get probability of getting a white ball. So this is going to be probability of P intersection W plus probability of Q intersection W, which I think is also a half. So this is going to be a half times 6 out of 10, then plus a half times 2 out of 5. Does it still give us a half?
Yes,
This is
teacher.
It gives us a half. Okay. Then from there, we are going to say our probability of Q given W, which is probability of Q intersection W divided by probability of the white, which we have just got. So probability of Q, so we're going to get it here, it is a half times W, which is of the intersection, which we are picking from Q, which is 2 out of 5. Then this divided by a half. So I think the half cancels out. And then we remain with the 2 out of 5. Any questions?
Teacher,
Yes, please.
where is the half coming from before you draw these boxes?
A half before?
Before these boxes that have the 6 white
Okay, good.
cards and
Good question. Now, they have told us that we only have two boxes, P and Q. So when we were beginning this number, I said if they have not given you any other condition, okay, it's like they are saying they put those two boxes in a, let's say in a bag, and tell you to close your eyes and pick. So when you're picking from that bag, there are only two options. You either pick a Q or you pick a P. So the probability of picking one of them is going to be 1 out of the total, which is 2. So that is where we are getting a half and a half. Is it okay?
yes, teacher.
Okay, good. Let me plug in my battery bit and then continue. Okay, our question 4 reads, a bag contains 4 red balls and 3 yellow balls. Another bag contains 3 and 2 yellow balls. I think the 3 were red, 3 red balls and 2 yellow balls. A ball is taken at random from the first bag and placed in the second bag. So here we are going to be following these statements. So we have 2 bags, bag 1, or what they are calling the first bag, and then the second bag. So we are picking a ball from the first bag and placing it in the second bag. Then a second bag is shaken and the ball is taken from it to the first bag. So if the ball is now taken from the first bag, what is the probability that it is red? So let me give you some 1 minute to read and understand the question more so that we do it together. I guess you're done reading. So we are going to begin by constructing our first bag and second bag. So we're going to begin with the first bag. So in the first bag, we have 4 red and 3 yellow. So we are picking from the first bag and then we place in the second bag. Now, if we pick red, the probability is going to be 4 out of 7. If we pick yellow, the probability is going to be 3 out of 7. Now we are going to create the back branches going this side so that they remind us of what is there if we pick, because we are going to come and add again. If we pick red, what remains in that bag? What remains in the bag and what remains there after we have picked our 2 different colors and yellow. So if we pick red, what remains? What remains in the first bag? Hello? If we pick red from the first bag, how many red balls remain there and how many yellow balls remain there?
Teacher, 3 red, 2 yellow.
How about if we pick yellow?
2 yellow and 4 red.
Okay, good. Then, so we are picking a ball is taken at random from the first bag and placed in the second bag. So what do we have in the second bag? We can also draw it somewhere down here and we call it second bag. Second bag has 3 red and 2 yellow. So if we add a red ball to the second bag, how many red balls are there?
The first 4 red balls.
4 red balls, thank you. 4 red and 2 yellow. Then if we place there a yellow, the red remain 3, and the yellow also increases to 3. Are we there? Now we are going to pick. So we're going to now shake the second bag. This is where we have added our balls. So we are going to shake it and pick a ball and place it in the bag. So let me create branches there. So we are going to pick our balls and place them back in the first bag. Remember, in the first bag, when we picked the yellow, when we picked the red, we remained with 3 red and 3 yellow. So when we are in this upper branch, that is where we are going to place back. If we picked a yellow first, a red first from that bag, and now we are placing there, that is the bag where we are going to do what? To place. So in other words, we are going to be bringing our balls here for this upper branch. Is that understood?
Teacher,
So we are
can
going to pick a red ball. So the probability here is going to be 4 out of 6. A yellow ball. Okay. I was saying that this is now our second bag. Okay? This one here. So we are going to pick a ball from this second bag and place it in the first bag where we had removed the red. Okay? Because when we remove the red, we remain with 3 red and 3 yellow. So since we are now in the branch of red, we are going to use what remained when we picked the red. Understood?
Yes, teacher.
Hello? Should I proceed?
Yes.
So we are picking a red ball and placing it in the first bag where we had our red. So if we place it here, okay, so we are removing, yes, we are removing a red ball from this bag and placing it back to the first bag. So how many shall we have? How many red balls shall we have now in the first bag?
4 red.
Ball and a red Chantel, can you and Shane, can you transfer the host rights back? I cannot share screen.
Teacher, how should I do that?
You click on my name, you right click. Let me see. Okay. It has come. Now my diagrams have disappeared. Okay. But had you got what I was explaining?
No, teacher.
Wow, the number is becoming hard. Okay, let me begin again. So we have our first bag there. And then we said we are going to create branches that are going backwards. And then we remove. So if we, so we're going to let us just follow step by step, okay? So in the first place, we have the first bag containing 4 red and 3 yellow. So we're going to either remove a red or a yellow. Are we there? So if we remove a yellow, if we remove a red, the red ones we said are going to reduce to 3, and the yellow ones remain as 3. If we remove yellow, the red ones are going to remain 4, and then these are going to reduce to 2. Okay, so this part, this left part, we are putting it there to head a pass, so that when we are coming back to add, remember we are picking a ball from the first bag, we place it in the second bag. Okay, after doing that, we again shake the second bag, get a ball and place it in the first bag. And then we now pick a ball from the first bag, and then we see the probability that it is red. So why we are creating this these 2 bags on our left is to enable us in the process of transferring the ball from the second bag back into the first. So if we draw our other 2 bags here, so this is the second bag. Remember, we had placed the second bag here. This was the first. So if we pick red from the first bag and place it in the second bag where we had 3 red and 2 yellow, the red ones will increase to 4, while the yellow ones will remain 2. If we pick the yellow ball from the first bag and place it in the second bag, we shall remain with 3 red, and the yellow ones also increase to 3. I think that is where we had stopped. Then we are going to now pick pick from the first bag. Let me just first use one branch where we picked red. So we are going to pick a red from this one, which is now the second bag where we have added, and we take it back to the first bag. So this is now going to be the first bag where we are adding, the one where we had picked a red. When we picked a red, the red one is reduced to 4. So now when we come back and we are adding, so if we pick a red ball from the second bag, so from this second bag, and we place it back in the first, so the red ones are going to increase to 4, while the other ones will remain 3. Now, if we take a yellow ball there, the red ones will remain 3, but the yellow ones, because we are adding a yellow to the first bag, the yellow ones will increase to 4. This is now we are adding our ball back into the first bag. And then let us just complete with this branch here. And then our statement now says, because we are now here, if the ball is now taken from the first bag, so we are now picking from the first bag. What is the probability that it is red? Okay, so that was the first branch. So we come back down here. Now we are still going to pick a ball and add it to the first branch, to the first bag. Now the first bag for this lower branch is now this one here. So if we pick a red or yellow, it's somewhere here where there is a mistake. That should be yellow. If we pick a yellow, a red from here and place it here, the number of red balls increases. So the number of red balls is going to increase. We are picking from this second bag and place it here. So remember here there are 4. So when we add 1, they become 5. And then the yellow one does remain 2. If we place there the yellow, these ones remain 4, the red remain 4, the yellow increases to 3. And now we pick a ball from each of these. So this would be red or yellow, red or yellow. So we can now put the probability values. Let me just use a different color. So the probability here will be 4 out of 7. The probability here will be 3 out of 7. Now we leave what is on the left. That was helping us. Okay? That was helping us. So we can now leave them out. Then here it will be 4 out of 6. 2 out of 6. 4 out of 7. 3 out of 7. This is 3 out of 7. 4 out of 7. And we come to this lower branch here, 3 out of 6, 3 out of 6. This would be 5 out of 7, 2 out of 7, 4 out of 7, and 3 out of 7. So our interest is the red bag, the red ball. So I'm going to pick interest where we have only reds. So this is going to be red 1, intersection red 2, intersection red 3. Then also have this red, begins with the red 1, intersection yellow 2, intersection red 3. Then also have this red one here, begins with yellow 1, intersection red 2, intersection red 3. Then lastly, we have this one, which begins with yellow 1, intersection yellow 2, intersection red 3. So since I have limited space, let me just use this space here to multiply, and then we shall add. So the first one is 4 out of 7 times 4 out of 6 times 4 out of 7. And this one here is 4 out of 7 times 2 out of 6 times 3 out of 7. This one here is going to be 3 out of 7 multiply it by 3 out of 6 multiply it by 5 out of 7. Then the last one is 3 out of 7 multiplied by 3 out of 6 multiplied by 4 out of 7. So what is the answer for the first one? 4 out of 7 times 4 out of 6 times 4 out of 7.
Teacher, the answer is 32 out of 147.
Okay. The second one? 4 times 2 is 8 times 24.
Teacher, 4 out of 49.
24 out of?
4. 4.
Four.
Just 4 out of 49.
4 out of 49.
Yes, teacher.
Okay. But I would suggest we leave them to the same the same LCM, same denominator, because it will be easier for us to add. Are we getting the same answers?
Yes, teacher.
Okay, then we now add the total. What will be the total?
Teacher, I'm getting
Yes.
107 out of 147.
107, eh?
137 out of 147.
137. Good. Wow. Now, when you get it, when I send it, please write it in an orderly way, not like the way I've written it here. I've written it like this because of the challenge of space, okay? Because I wanted it to fit on one slide. So I have it on one what? On one slide. But when you get it, try to arrange it better, okay? Any questions? If there are no questions, we can stop here for today.